This is the activity number 8. It's about the analysis of sequential circuits. We are team number 3 and we are Melissa, Alberto and Paul. The first problem is the letter B and the first step is to get the equations. We can see that we need to get the D and the C. Here are the equations and we can see that the D is an OR composed by the X and the Q inverted, and the C is also an OR composed by the X and the Q. The second step is to build the truth table. As inputs we have the X and the current state, and as outputs we have the next state and the D and the C. These two columns we get them with the equations, but to get the Q we need to see how does the flip-flop D works. And here we have the truth table. We can see that for a 0 we get another 0 and for a 1 we get another 1. So we just copy the same number like we do. The next step is to build the state table, and this is how we build it. We have a current state of 0 and an x0, so we are in this line. And for this combination we get a 1 in a Q and a 0 in the C. The next one is a current state of 0 and an x of 1, so we know that we are here and we get a 1 and a 1, like it is written here. The next one is the current state of 1 in the x of 0, so we know that we are in this row. We get the 0 over a 1, and the next one is a current state of 1 and the x of 1, so we are in the last row, and we get a 1 over another 1. The next step is to build the state diagram. In the first step we are in the current state of 0. We have an input of 0. So this tells us that we are going to go to the state of 1 and we are going to get a C of 0. And the second one we also are in the current state of 0, but here we have an input of 1 and we are going to go to the current of 1, so the arrow is in this direction, and we can see that we get a C of 1. Now we are in the current state of 1, so if we have an input of 0, we know that we need to go to the state of 0, and as C we have a 1. If we are in the current state of 1 and we have an output of 1, we need to go to the state of 1, and as C we also have a 1.
This is the second exercise for us, our team. The exercise D. This circuit has no input or output. We only depend on our flip-flops type D. We have 3 in this circuit. Then we obtained the value of the formulas of our circuit, of each input D of each flip-flop. In this case, we have that D sub 0 is equal to Q1, Q2 inverted. D sub 1 is equal to Q0, and D sub 2 is equal to Q1. We have also the truth table or state table of the flip-flop D. We have that when we obtain a 0, the output is 0, and when the input D is equal to 1, the Q is equal to 1 as well. Then we complete the state table of our circuit with the 3 states, Q0, Q1, Q2, and the next states, Q0, Q1, and Q2, and the inputs of the flip-flop D0, D1, and D2. Also, we organized the each state with letters. Letter A for the first state, letter B for the second state, and so on. And in the final column, we have the next state. It depends of our value of our output. Finally, we do the state diagram according to the state table. We have a state and the next state, and we match each state with an arrow. We don't we didn't put the name of each arrow because we don't have an input or an output in this circuit.
So this is our solution of the problem E. This is our equation that we obtain of D1, D2, D3, and C. Also, we have some truth tables that we use, like the XOR truth table and the flip-flop type D. This is our first part of our truth table. We have 2 inputs, 3 current states, 3 next states, 3 inputs of the flip-flop, and 1 output. The cells that are in color, we are going to use it in our diagram state. This is our second part of our truth table. As we can see, there are some columns that are in one kind of color. So this we are going to group in input state. So we're going to do this next. The lines that are in red, these are going to be when our output will be 1. So we already have called the states as a letter, either the current state and the current input in this case. So we obtain this state table that we are going to use to do our state diagram. So we are going to do the state diagram. We call the current states that are our Q's as A, B, C, D, E, F, G, and H, and our current inputs as R, S, O, P. So we obtain this. This is our state diagram. This was what we want. So we already have finished. So as you can see, there are the current states linked to the next states, respectively with their inputs and their respectively outputs.